56. Rules of inverses say switch x and y and resolve. Okay? So if I just look at 56 right away, if I flip-flop x and y on 56, I get x is log base 9 of y. In order to get y by itself now, I need to use the properties of logarithms. So when you go back to all the different properties that we had, there were, not all of these, there was what, 2? We said b to the log base b of x was x, and then log base b of b to the x was also x. Okay? So when I look at these two here, I need to use one of these properties to both sides of the equation to undo it. So I need to do this. I need to exponentiate the log. I'm turning it into an exponent. In order to turn it into an exponent, I put a 9 here and a 9 there to keep it balanced. So now you have 9 to the log base 9 of y. Well, these bases are the same, so the y drops. You get 9 to the x. It's that fast, okay? It's literally that fast. Yes, sir?
Do we have to show our work on every single one?
No.
Or can we eventually just like so?
You should be able to, it's fine. Okay, absolutely fine. Same thing with 60. If you look at 60, if you rewrite this right away, you get y equals log base 7 of 7 to the 2x. What's log base 7 of 7 to the 2x? What happens there?
2x.
You just get 2x, don't you? Now, I have not flip-flopped my x and y yet, so now if I flip-flop my x and y, x over 2 is your inverse. So sometimes you use the properties to help simplify it out prior to getting to it. Okay? Same as 1/2 x, yes. Go. Sure, I'll get you next time. Log base 4 of 1/2. So I had to figure out how do I write 1/2 as a base 4. Excuse me. So let's see, log base 4. How do I get 4 to what power equals 1/2? Negative 1/2. So then my answer would be negative 1/2. Okay. You sit there and think of how do you get that base to the base to what exponent equals 1/2. So the trick was whenever you see whole numbers and fractions or fractions and whole numbers, is that your exponent that it was raised with had to have been negative. That's how you flip them back and forth. Okay? We have an option. Sure.
No,
because if it's negative, because then it gives me the square root to get me to the, because then this would be 4 to the 1/2, which would give me 1 over 2. And this is the style that's always the messiest when you have whole numbers and fractions, because you start going, wait, it should be this, that. When you get to that part, just double check it and just work it through real quick to make sure. Lord knows I've screwed it up before too. What was that? Had that one on you, didn't I? Same idea. When you go to this one, first things first, flip-flop x and y, but I'm also going to rewrite it as log base e. Okay? Anytime you have natural log and you have to do something with it, rewrite it as log base e. Oops, sorry, that should be a y. Once again, I need to undo the log. In order to undo the log, I have to exponentiate it. Okay? So this becomes e to the log base e, which means this is e to the x. These guys drop, you get e to the x, y minus 1, e to the x, plus 1, is y. The trick here is to make sure when you have your plus 1 tacked on, don't float it by mistake to the exponent. I see that every year. I'll see something do that. Don't do that. Okay. That's how you undo a log. You exponentiate it. Logs. No. It's big. It's heavy. It's wood. It's better than bad. It's good. All right. So let's talk about graphing them real quick. So when we graph logs, we're going to be basically working with a generic setup again. We're going to have y equals the log base b of x minus h plus k. When we deal with graphing of these, I've always been joking around. What do logs come from? Trees. Trees grow what direction?
Upwards.
So that means logs have vertical asymptotes. It's bad, it's dumb. Hello!
Monday. Tuesday. It's Monday. Nice.
The exponential one has a horizontal, inverse it has vertical. Okay, and that's how it works. So again, what happens with logarithm stuff is that you're going to have a parent function and a shift. Our parent function is just going to be y equals log base b of x. And then your shift is just, again, is your x plus h, or plus or minus h, and then your y is plus or minus k, how those go through. Now, what's weird with log graphs, as far as the parent functions are concerned, it goes back to the idea that you guys there's no clean numbers, but we gotta look at our old properties. Log base b of b equaled what? What was that one from yesterday? It equaled 1, right? Good. And then log base b of 1 equaled what? 0. So what happens for your parent functions for logs, there's only 2 ordered pairs you can work with. Your parent functions will always be, excuse me, b comma 1, 1 comma 0. Those are the only clean ordered pairs you'll ever get for log graphs. B comma 1, and then 1 and 0. And then from there you just shift it. Whether it's a positive or negative h, positive or negative k, moving it left and right. Your original asymptote for the parent is at 0, vertical line at 0. And then when it shifts, it just goes to whatever h is. Okay? So your asymptote is at h. X equals h is your asymptote. X is greater than h is always your domain. And range is all real. Okay. These graphs only can go 2 directions. If the b value is greater than 1, it's moving up and right. If it's between 0 and 1, it's moving down and right. There's only 2 directions for them. Okay. It's very easy to see when you plot those 2 points. You'll see which way they're moving. All right. Graphing of logs is one of the easiest ones that we do. Okay. Easiest ones we do. So, for example, let's do. Sorry, I have to put that on here. If b is greater than 1, it does this. B is between 1 and 0, it does this. That's just the generic shape of the graph. I didn't get too far ahead. Hi, how are you? Arrivederci. Range. Range is all real. Sorry, I was trying to make a joke and it didn't work. Arrivederci. Goodbye. Arrivederci. Anyway. Let's graph this one. We'll walk through how to do parent and a shift. Okay. So when I graph these guys again, I'm going to label out my paired ordered pairs, my shifted ordered pairs, and plot out where my original asymptote is, final asymptote is, and then domain and range. Just like we have been with all the other ones. Okay? So remember, whenever you have your parent function for these guys will always be b, whatever your base is, in 1, and then it has to be 1 and 0. Those are the only two ordered pairs you have to come up with. And then honestly, you only have to think about one number. And that is, what's b? So what's b in this case? It's 1/3. Okay? So our b value for our parent function, our ordered pairs will be at 1/3, comma, 1. Because remember, what this means, I'm checking what is the log base 1/3 of 1/3. 1. That's what we're checking. Okay? There's just no reason to write it. And then the other one would be at 1 and 0. So to these ordered pairs, excuse me, I have to shift them. My shift was, what's my h value? 3. What's my k? 4. So it's +3, +4, so it's x plus 3, y plus 4. Is it okay to use a mixed number here? Again, I wouldn't try and go through and do mixed or a top-heavy fraction. There's no reason for it, especially since we're just plotting some points. It's always a lot cleaner to use a mixed number from time to time. This is one of those times. So my shift would be at 3 1/3 and 5. And now the toughest one. 1 plus 3.
5. 6.
So sad.
-7.
-7. Here we go from there. Okay. So now we have plenty of information now to plot. So we'll split this up. I don't normally use graph paper, but just for fun, we'll do it once. So this one here, and whatever. Parent was at 1/3 and 1, here-ish. 1 and 0, here-ish. We had our asymptote here. There's only 2 points, but I know that it's got to be moving from top down, so I just kind of make a little swooshy curve. So on and so on. Okay, and then I do the same thing with the parent. I'm sorry, the shifted, excuse me. 3 1/3 and 5. 1 little, 2 little, 3 1/3 and 5. And 4 4. Asymptote was now at 3. Yeah, asymptotes are always out.
Is the asymptote that's always 0?
Yeah, because there's no h. Your parent has no h, so your h value, or sorry, the h value here is 0. No. H and k. Our h value was 3, so it went over 3. Yeah, remember, if it's minus h, it means it's plus. Yep. Yes, sir. Sorry, go ahead. That h. Oh yeah, that's good. Grab one. We'll get the first part of it. I wanted to get a little bit of this started up because this gets messy if you don't see a little bit of it. Okay. And then lastly, I've got my asymptote at x equals 3. My domain, x is greater than 3. My range is all real. Graphing. As you can see, we do not need to spend a day on this.
What's it? 10 minutes? Maybe?
Yeah. Yes, sir.
Why would I regularly calculate?
Because it gets infinitely smaller as it moves through, and it dives itself through. Okay. It just becomes, if you look at the table, you probably have a bunch of E buttons, because it drops off, it drops closer and closer to the asymptote really rather rapidly, because the rate of increase is getting there, it just goes crazy. Okay. That's why it looks like that.
Very small.
You know what I'm saying? how it gets those leaky stuff, and that's what it does. No big deal. That's why we don't rely on the graphing calculator. We rely on our brains. I know, right? Okay. So let's talk about this then. I was doing this with first hour as well, and the reason we were able to get through the graphing stuff rather easily. So I decided just to go ahead and just start doing 8.5 today. So we'll get through the majority of the properties today, do some expanding and condensing. We'll get to a little bit more of the nuttier stuff of it tomorrow, which will allow us to do equations a little bit earlier, which just means that our test on all of this stuff will be next Tuesday. Okay, so I remember I was saying yesterday it's going to be either Tuesday or Wednesday. It'll be Tuesday. If we're cruising right along, no worries about it at all. Okay, so we're going to mix into this one with some of the properties of logarithms. And remember, we just did this one a second ago as well, where we wrote out, what do I have room? Not enough board space today.
Wait, what is?
It was a snake charm that we found once, and I don't know whose it is, and it's been there for like 4 years. So are you missing a snake charm?
So you just have that for good luck.
Sure.
If snake means the box, yes. But snakes are amazing. You can do so much with them.
It's like when you have
So we had those other two properties. So here's what's going to happen. Today we're going to talk about ways of rewriting logarithms. A lot of times we can rewrite them to help simplify them easier. So one of the ones that we look at is we can take a logarithm. Now, this sounds weird, but what this is saying is the log base b of u times v, and I can split that into two separate logs. The reason why we like to split things apart is sometimes logs can be simplified. Okay? So this is kind of where we're headed towards. Well, how do we use logs to simplify larger composite numbers, and so on and so on. So, for example, think of it this way: when you have multiplication, it is kind of like repeated addition. So that's an easy way to remember this one. So if you've got the log base b of 2 things, or 3 things, or 5 things, or 70 things being multiplied together with the same log base, you can split them apart into individual chunks. Okay? And I'll show you an example. I'll split the screen here and do another example of it. So if I say the log of 3x. First of all, what's the base of that log?
10.
Why is it 10?
Because it's a natural.
Because it's a common. Natural would be ln. So that's just base 10 because it doesn't say it, so it's got to be base 10. This is log base 10 of 3 times x, or 3x, which means you can rewrite it as log of 3 plus log of x. Yes. Okay. And as we get into some of the numerical simplification ones, you'll see why we can do these things and why it actually works. You've actually done the properties, you just didn't realize we were doing it earlier.
Wait, so would that mean log 4 plus log 5 would be 1?
Yes, sir. Yep, that's exactly what that means. Or it can be log of 2 plus log of 2 plus log of 5. Because if it was log base 2 of 20, I can rewrite that as log of 2 of 2, log base 2 of 2 plus log base 2 of 2 plus log base 2 of 5. Then you can simplify it out. What's that? Kind of, yeah, that's a good way of looking at it. It's a little bit like that, where you can simplify certain things through. Yeah, that's a good way of thinking it. Okay.
That makes sense.
Division is when you have the division bar. If you split it apart and get rid of the numerator and denominator, it looks like it looks like a subtraction bar. Anyway, it's really not. But think of it this way: log base b of same base u divided by v. You can split it up into a subtraction part. Okay. And like you were saying, condensing. If you go back the other way, what we're doing is expanding. And what your example was bringing it back in, it goes back and forth. Okay. So here an example would be log base 2 of 7 over x. I'm just coming up with dumb things. That just means it is log base 7, or excuse me, log base 2 of 7, subtract log base 2 of x. Yes, they continue the same base. Okay. Since it started with the same base here for those two parts, the same base goes all the way throughout. Yep. And then the last one we look at is also pretty simple. Log base b of u to the n, so the n is the exponent. You just bring the exponent in front of the log. Okay, you just bring the exponent up in front of the log. For example, if I say it's log base 3 of x to the 5th, I can rewrite that as 5 log base 3 of x. So we got three properties. Can't even write.
It's a Monday. It's Tuesday. It's a Monday. It's Tuesday. It may be a Tuesday, but it's a Monday.
And I'll show you how this is all going to work here in a second with a couple examples. I just wanted to write them out. Okay. So far, so good? I don't know if there's a name. Exponent in front. No, not that I know of. Logging an exponent? Maybe? Deforesting? I'm just making stuff up. All right, so let's look at this. Let's split this into two. So here's what's happening. And I'm going to show how this stuff works with properties you guys have already done versus these new ones. The first example, it says log base 3 of 3 times 9. So that's multiplying the two things together, which means you can split it apart as 2 separate logs. Okay? So when you split it apart as 2 separate logs, you wind up with log base 3 of 3 plus log base 3 of 9.
You can split a 9 into 3.
What's that? Yeah, exactly. That's what I was just getting at. Because what is log base 3 of 3? 1. It's 1. Okay? What's log base 3 of 9? 2. Remember, 9 can be rewritten as a base 3 as 3 squared. I don't care.
Always comes at the best of times.
I know, right? And then that's what I can drop. I mean, I can move this out front then too if I wanted. I can have 2 times the log base 3 of 3. Well, what's base 3 of 3 again?
1.
1. So what is 1 plus 2? 3. Now, the answer is 3. Yeah. Now, what's 3 times 9? 27 is 3 to what power? 3. What's log base 3 of 3 to the 3rd? You already knew how to do this. You just didn't realize there were properties from it that could break them apart. Okay. Second one. Log, waiting.
Oh, wait, okay. 2.
I was so glad I waited. What do I do with the second one? Bring the 5 out, right? If I bring the 5 out first, I get 5 log base 2 of 4. What's 4 as base 2? 2 squared, right? So can I just rewrite that real quick as 2 squared? Now what happens? Exactly, so you get 5 times 2, which is 10. Or if you started at the beginning, if you noticed, 4 can be rewritten as base 2 right off the bat, couldn't it? If I did that, I would have had log base 2 of 2 to the 2 times 5. Log. If I rewrote the 4 right off the bat. Because if you notice, you still get the same solution. It depends on how you see it. There's no one size fits all with a lot of these things. You can get, you'll still get there as you meander through. It just depends on how you see it. Okay. All right. Division. Once again, if I write this up, yes, sir. Yeah. How do you find times 2? When I got to here, I had log base 2 of 2 squared. Those two bases drop. Remember the x1 will just come down. Remember the rule? Log base b of b to the x just as x. Since the bases are the same, the exponent drops. That's what I keep. Okay. So if I look at the next one, if I do one with the division, if I split this into the 2 separate parts, I get log base 3 of 1. This is just not there. Log base 3 of 1, bless you, minus log base 3 of 3. What's log base 3 of 1?
0.
0. What's log base 3 of 3?
1.
What's 0 minus 1?
-1.
Isn't 1/3 greater than -1? Okay. Isn't 1/3 1 divided by 3? That's why. Okay. Log base 5 of 1/5 all to the third. Again, if you split this apart, you've got the exponent first, so you can bring the 3 out front, then you get log base 5. We'll put parentheses around this, of 1 minus log base 5 of 5. Now, the reason I put parentheses around that is because that whole fraction is raised to the exponent. Anytime you see that, you want to make sure you throw parentheses, okay? Because that 3 gets distributed to both parts. What's log base 5 of 1 again?
0.
0. What's log base 5 of 5? So you get 3 times the quantity 0 minus 1, otherwise known as?
-3. 0.
Yeah. Because once again, if you look at the original problem, isn't 1/5 5 to the -1? And then you have 5 to the -1 to the third, power to power, you multiply, you get -3. Okay. Does this change with variables?
Nope.
Nope. The only thing that'll change a little bit is that they'll put the little caveat in there that assume that x and y and z or however many variables are always positive, because we don't do logs of negatives. Okay. So here again, I want to expand. When you see expand, it means you're going to have multiple logs. We're going to branch out. That was bad. Now again, notice you've got a division bar here. The numerator has multiple parts to it. There's 2 parts to the numerator and only 1 part to the denominator. That means you got to remember to put parentheses around everything that's from the numerator. Right? That's the biggest trick that people forget. So we split this up. We have log base 2 of 7. Then what do I write? It's 7 times x to the third. So what do I write next? Plus.
Wait, isn't it minus?
No, log base 2 of x cubed, but it doesn't have an exponent. What do I do with that exponent? Bring it out in front. Now, since that's all of the numerator, then you subtract the log base 2 of y. You throw parentheses around the whole numerator to denote that it's all being divided by y. Okay? That's just a little trick thing that you'll see. Okay. And obviously, when you start to write that up, that second log, where you had the log base 2 of x cubed, as soon as you write the x cubed, you probably would have been, oh, nuts, it's supposed to be out in front. Just erase it and put it there. Yes, sir?
So, when it's expanded, we're just trying to make it like bigger?
Yes.
How it used to be?
Yes.
Okay. So, opposite is simplified.
Correct.
Okay.
So this would be
To complicate.
Would you do anything else?
The opposite of simplify. Never mind. Okay. Condense. Condense means you want to write it as you want one log. Think of it as you want the one Yule log. It would have been a lot funnier if Miss Yule was here because she was my student teacher last semester and she taught this. She would have liked that one. It was a Yule log, single log. She's doing really well. I texted her about a week ago. She's doing really well. She's at South. Good times. So when you're condensing stuff, one thing that the textbook tends to forget from time to time is you notice how it's got addition and a subtraction? That means there's multiplying and dividing. That means this had to happen. Okay? What's the base of this log? 5. Why am I so awesome? Oh, there was a number.
Is that what that is? Yeah.
Anyway, so when you have this, first of all, what's the base of this log? So we have log. What's the numerator going to look like? 6 times 2 squared, and then all over, okay? Order of operations. What do you get? You don't like this? It doesn't get that bad. Listen to how horrible you think this is. Man! What's 6 divided by 3? 2. What's 2 times 2 times 2? Log 8. Simplify what you can. Alright? Alright, so this is 1/2 log of x minus log of 4. And you want to condense this. Okay? Throw my desk, it's fine. So hopefully you got this. Hopefully you started with that. Okay? Did you write it as x to the 1/2?
Yeah.
Isn't that square root of x? Either one is fine. Yeah, this is the same thing as this. Log x to the 1/2 over 4. They mean the same. Okay. I always write it as the square root of x because you guys are so used to, because if the rules were just to move the exponent around, you guys always get the habit of just doing the same thing. So I just rewrote it as what it meant. Everybody goes, what? And then you remember. All right. So what is all this log stuff going to allow us to be able to do? Well, eventually, it's going to allow us to get to something like this to be able to solve. Okay. Now, this is natural log. Now, natural log is log base what? E. So are all of these bases the same? Yes. We will, yes. But first, before I do that, I have to condense. What side do I condense? The right side. Okay? So what this means is I can get to the point of, and this is where we're headed towards, maybe a little bit tomorrow, I'm not sure how far we'll get along to this, is I know I can rewrite this side as the natural log, or actually, you know what, I'll write it as log base e for right now. So we'll go log base e of x plus 5 is log base e of the quantity x minus 1 over x plus 1. Because that's what the subtraction symbol is. We're dividing. Okay? Now, if I was to continue to try to solve this, what would I have to do to both sides of the equation? Not multiply. Exponentiate. Is that a word? If you're in college, you should know these things. Yeah. It sounds like a great word. So, yeah, Murphy says, trust me, if anything can go wrong, it will, I know. So now I've exponentiated, what happens with my logs and my e's and my stuff? They all drop. And you wind up with just x plus 5 equals x minus 1 over x plus 1. From here, what would you do to continue on your merry way?
Multiply by
You would cross multiply through and you'd have to factor and solve, but we're not going to worry about that today. Okay? The idea here is that the reason why we work with condensing or expanding is so that way you can get to the point of working with equations. Okay? By using some of the properties, we can get there with these things. All right? I think that's all I really had with this stuff. I don't think I need any more of them. Go back here. Oh wait, sorry, here. There was one other thing that this section talks about. It talks about what's called change of base. We'll never do it. That was for when before calculators had the alpha window 5s. There's no reason for us to learn how to do that anymore at all. Plus, it's just silly. Okay. Homework-wise, what did I put on there? I made 2 questions. Let me pull this up real quick. Yeah, what I did was the textbook doesn't do a really good job of writing up problems for graphing with this stuff, so I just made 2 really fast, and then I put it in with which time did I save that? Get off the desk, you bum. It's loading. No worries. So what I did here was I made up really fast 2 graphing questions for you guys to do. These 2 are not in the text, so please write those down, take a picture of them real quick. And then the rest of it are just expanding and condensing of the logarithms in 8.5. As of right now, the 8.5 PDF is on tomorrow's date on the calendar. I'll switch that here in a minute and put it on today's, so that way you have that. Otherwise, you'll find it on tomorrow's. It's not that big of a deal. And then tomorrow what we'll do is I've got a couple of the more of these expanding, condensing problems that get a little funkier, if you will. And then we'll probably start maybe a few of the equation things and go from there. All right? Did great today. Yeah. I said everybody did great. You did great.
Annika, you did great. I was like, he didn't say my name. I don't think he remembered. He said you.
Your name?
He said you did great. You didn't say my name. I don't think he was. You tell me I did great. I won.